All right, so today we're going to start chapter 8, which is all about rational expressions, which really is a fancy word for it's a quotient of polynomials, which again is kind of fancy for fractions. This chapter is all about fractions. So get excited because they're not your grandma's fractions, they're not just 2/3. We're going to be having mostly fractions that include the polynomials that we've been uh, looking at in the last chapter. So we're going to be today just kind of looking at rational expressions and simplifying them as much as possible. And we do that by using a lot of the techniques we did last chapter. So you get a lot of extra practice this chapter with what we did last chapter, which is factoring. So before we get into that, though, remember that in a rational expression, the denominator can't end up being 0 because you can't divide by 0. So we're going to look at some of these problems are going to say find the value of this rational expression for the given values that are to replace it. So you're just plugging it in and simplifying that. So our first one would say 5 plus 4 over 2 times 5 minus 3. Simplify that. On top you've got 9. On bottom 2 times 5 is 10. 10 minus 3 is 7. Does that fraction reduce? No. So 9/7 is your solution there. If you were to plug in -2, you would have -2 plus 4 over 2 times -2 minus 3. Again, simplify. That's 2 on top. 2 times -2 is -4 minus 3, -7. Now, I don't really like the negative in the denominator of the fractions. In fact, mathematicians say, remember with negative fractions, you're supposed to change that to either the numerator, float the negative to the numerator, or float it out front. I typically will float it out front, -2/7. So if you ever have a negative in the denominator of a fraction for your final answer, just float it either out front or in the numerator. So that is also true with rational expressions. If you have an answer that looks like this middle fraction, that negative, it's weird. You want to either float it out to the top, which means you have to include the parentheses. Notice those parentheses have to be there. Or you would have to distribute that negative. One or the other is fine. Or you can float the negative out front, which again means you need to remember that you would distribute the negative if you're going to be combining like terms or anything like that. All right, so the next thing I alluded to earlier is a rational expression is undefined for values that make the denominator 0. Because remember, you can't divide by 0. It's like against the rules. So they're going to ask some questions. Will say, are there any values of x for which this would make the rational expression undefined? So how do you do that? Well, really, you set the denominator equal to 0. X minus 3 equals 0. So how would you solve that? You would add 3 to both sides of the equation, which means x would equal 3. So if x were 3, plug it in. 3 minus 3, that makes the denominator 0. So x cannot equal 3. So x can be all, so you'd say this like this. X is all real numbers except x cannot equal 3. Oh, I meant the double barred R for all real numbers. The second fraction, look at the denominator. The denominator is 7. No matter what I plug in for x, it's not going to change the denominator. So x can be all real numbers on this one because the denominator is just 7. On the next one, we've got one of those trinomials. So guess what you're going to do? Yeah, you're going to factor it. So what? This does not have a squared term. You're going to set it equal to 0. So x squared plus 6x plus 8 is equal to 0. There's no coefficient on the squared term, so we go straight into the parentheses. My third sign is positive, so we adopt the sign of the second for both, x plus and x plus. What are the factors of 8 that add to 6? 4 times 2, absolutely. Set each factor individually equal to 0. On the first one, x cannot equal -4. On the second one, x cannot equal -2. So x can be all real numbers except -4 and -2. On number 4. This one's interesting because if we look at x squared plus 5 and set it equal to 0, we can't factor that. This isn't a difference of squares or anything like that. So this one you just kind of have to think about. If you take a number and square it and then add 5 to it, is it ever going to equal 0? So think about some possibilities. A positive number. If you square 4, it just gets bigger, and then if you add 5, it gets bigger. So it's not going to equal 0. If you square 0, 0 squared plus 5 is still going to be 0. And if you square a negative number, negative 4 squared is still positive 16. And if you add 5, it's still going to remain positive. So this means that no matter what I choose, x can be all real numbers. Because if I square any number, it ends up being positive. And if I add 5, it's going to work out just fine as well. So there is some examples of that. So just set the denominator equal to 0 and think about it. The last type of problems and the most type of problems that you're going to see is going to be simplifying a rational expression. So to do that, there are 2 steps. First, completely factor the numerator and denominator. Second step, divide out factors in common. In other words, if there's something that matches on top and bottom, cross them out and then write what's left, and there you go, you've got your fraction that's simplified. So let's look at these examples. The first one, I've got in my numerator a GCF of 5. If I were to divide by 5, that would leave me with x minus 1. In my denominator, again, I have a GCF, this time of x squared. X cubed divided by x squared leaves me with an x minus x squared divided by x squared, 1. Oh my goodness, look at that. There's an x minus 1 on the top and bottom for factors. They cancel each other out, leaving me with the final simplified fraction of 5 over x squared. Number 2 is very similar. If I look at the numerator, there's a GCF of x to the 5th. If I take 5 x's from x to the 6th, that leaves me with 1x minus x to the 5th divided by itself is 1. In the denominator, both of those are divisible by 6. Divide by 6, and you've got x minus 1. Again, those factors on top and bottom match. They are able to be canceled out, leaving me with a final answer of x to the 5th over 6. And by the way, on these problems, we're assuming that the denominator does not equal 0. So you don't have to worry about finding what can x not be on these, like we did on the front of this page. Number 3 and 4, we bump it up a notch to those trinomials, but they're nice and easy to factor because there's no coefficient on the squared term, so we go straight into the parentheses. If my third sign is positive, I adopt the sign of my second for both, so I'm going to have x plus and x plus. And I just have to think, what are the ways that I can multiply to 7 that also add to make 8? There's only one option. 1 times 7 adds to 8. 1 plus 7 is 8. On bottom, this time my third sign is negative. So in my parentheses, I'm going to have an x plus and an x minus. And I'm looking for the factors of 5 that subtract to negative 4. So that means I would have a positive 1 and a negative 5. So again, now that it's completely factored, I look for matching factors. And again, x plus 1 on top and bottom match, leaving me with those that do not match of x plus 7 over x minus 5. Now, here you might think, well, can I cancel out the x's? Aren't those the same thing? No, you cannot cancel across addition and subtraction. You can only cancel across multiplication like we did. Notice all of these things are being multiplied on here. That's what allows us to cancel. These are being added and subtracted. You cannot cancel like that. If you think about numbers, you can't have, if you had like 12 over 5, you couldn't take 5 away from 12 and call it 7. That's not the same thing. 12 over 5 is not 7. So it has to be, you can only cross things out when they're being multiplied. So don't try and cancel those x out. 4 is very similar. We can go straight into the factoring. My third sign is positive, so I adopt the sign of the second for both of my parentheses, x plus, x plus. Factors of 4 that add to 5 are 1 times 4. On bottom, my third sign is negative, so I'm going to have 1x plus and 1x minus. The factors of 8 that subtract to 2. 4 times 2 subtracts to 2. It has to be a positive 4 and a negative 2. This time, I have x plus 4 and on top and bottom. Again, and it doesn't matter if they're straight on top and bottom. One's got to be in the numerator, one's got to be in the denominator. That leaves me with a final answer of x plus 1 over x minus 2. Again, don't try and cancel those x's out. On number 5, looks like we've got a normal trinomial on top. Our third sign's positive, so we adopt the sign of the second for both. The factors of 4 that add to 4 are 2 and 2. On bottom, it's not a trinomial. There's just a GCF of x in common. If you were to divide that by x, that leaves you with x plus 2. So I have one x plus 2 on top, actually 2 of them, and 1 on bottom, so I can just choose one of them to cancel with 1 on bottom. Remember, it's got to be on top and bottom. I can't cancel these next to each other. It's got to be 1 in the numerator, 1 in the denominator. And that leaves me with an answer of x plus 2 over x. Again, just like these ones, I cannot cancel these x's out because I cannot cancel across addition, only across multiplication. And that's what this helpful hint down here says. You can't factor out common terms, just factors. You can't divide them out. 6 is like 5. There's an x squared in common on top, leaving with x plus 9. On bottom, the factors of 81 that add to 18 are 9 and 9. X plus 9 and x plus 9. Again, I can cancel the matching factors on top and bottom for a final answer of x squared over x plus 9. I cannot cancel again one of those x's with one of these x's in the numerator because there's an addition sign in the denominator, not multiplication. So there's that. We'll move on to the third page. Let's see, just more examples of simplifying rational expressions. So you just got to pull upon those tools that we talked about in chapter 7. I look in the numerator and it's just x plus 9. There's nothing to simplify about that. In the denominator, I notice that difference of squares pattern. Hopefully you still remember that. So it factors very easily into the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So think of the square roots, 1 plus, 1 minus. On top, we have the x plus 9. So I am able to cancel those out. Now I've crossed out everything in the numerator, so what's left up there? The understood 1, and then in the bottom, I still have the x minus 9. On number 2 on the back, or the last page, again, very similar to 1. X minus 7 can't be factored. There's nothing to do with it. This, again, is a difference of squares. It factors to x plus 7, x minus 7. And once again, I'm able to cross out those x minus 7s, which leaves me with the understood 1 over x plus 7. And if you put the parentheses around, it's fine. It's just not necessary, so don't waste. Number 3, this one, it's just covering all our bases, make sure we see all of the examples. Look at the denominator. It's not in the right order. It's not in alphabetical order. You can rewrite that as x plus y. So look at that. Top and bottom are exactly the same. Something divided by itself is 1. If you cross everything out, you're left with 1. Don't put 0. Number 4, now this one, don't get fooled by number 3. This one is not 1. Again, the denominator is not in the right order. Think of that as negative x plus y over x minus y. Now, this one is tricky. Remember, when factoring, we don't want our first term to be negative. So we really want to factor out the negative 1 in the denominator. If we were to factor out a negative 1, that would make it x minus y. And now we have those matching numerator and denominator. But it's not just 1, because it's really 1 divided by negative 1, which is negative 1. So that one turns out to be negative 1. So if you can just remember that if they're kind of opposites but with negatives, it's going to end up being negative 1. So that might help you. Okay, let's look at 5 and 6 that are pretty similar. So again, 5 is not in the correct order, so I would rewrite it as negative x squared plus 4, which I see that, and I'm noticing, hey, it's probably going to be a difference of squares. If I factor out the negative 1 that's in common, that leaves me with x squared minus 4, which that is a difference of squares, right? So we know that that factors 2. Don't forget the negative 1 that's out front. X plus 2 times x minus 2, the square root of each of those terms, one positive, one negative. And the denominator, that one takes a little bit more work. That's one of those trinomials with the coefficient that's bigger than 1, so that's going to take some more work by making the magic number. 3 times 2 is 6. I'm subtracting to make negative 5. So 1 times 6 or 2 times 3 are my options. Which one subtract to make negative 5? The 1 times 6. So it'll be a negative, I guess a positive 1x and a negative 6x. Everything, I kind of ran out of room. Let me rewrite that. 3x squared plus 1x minus 6x minus 2. All right, we made that 4-term polynomial on purpose for a reason, to factor it by grouping. Look at my first group, what's in common? An x, divide by x, you're left with 3x plus 1. Second group, we don't want our first term to be negative, so we're going to factor out a negative 2. Divide by negative 2, and you've got 3x plus 1. So, we know what this factors to. I'm going to go ahead and put it underneath my fraction over here, the 3x plus 1s that are in common. And then the leftovers, x minus 2. You look at that, and you should hopefully notice that there are an x minus 2 on top and bottom, which are able to cancel out, leaving us with an answer of negative, I'm not going to put the 1 this time, x plus 2 over 3x plus 1. I don't need the parentheses in the denominator. In the numerator, you could have floated the negative out front and dropped the parentheses, but I think this is a better way to put it, so I would keep it like that. All right, that was a jumbled mess. Let's try 6. Maybe I can keep it a little more organized. Okay, I'm going to work up on this one. So again, I got to make a magic number of 24. Factors of 24 that subtract to make negative 5. Well, 3 times 8 subtracts to 5. It's got to be a positive 3x and a negative 5x. 8x, not 5x. 8x. Rewrite the minus 12 and the 2x squared. And we made that to group. What's in common in that first group? X, divide by x, 2x plus 3. Second group, don't want a first term to be negative. They're also divisible by 4, which would give you 2x plus 3. So we know what this is going to be a final numerator of, 2x plus 3 that's in common. And then the leftovers, x minus 4. And the denominator, again, I see that it's in the wrong order, so I'm going to rewrite it as negative x squared plus 16. Don't want my first term to be negative. So I'm going to factor out the negative. X squared minus 16 factors to the negative x plus 4 times x minus 4. And that's great. Those minus 4s cancel. And then I would not leave that for my final answer. The negative in the denominator is awkward. Float it up to the top. Negative 2x plus 3 over x plus 4 in the denominator. Okay, and then numbers 7 and 8 are just reiterating the thing with the negatives. You can float it to the top, so an equivalent form would be negative 5x plus 1 over x plus 9. You could float it to the bottom, but I never would. That would be a terrible answer, like this. That's not good. You don't want negatives like that. You'd want to simplify that. That's really about it. And then 8, exact same. Distribute the negative in the numerator, and you'd have negative x minus 3 over 6x minus 11. Or, if you distributed the negative to the denominator, it'd be x plus 3 over negative 6x plus 11, which isn't a great answer, but it is equivalent, so keep that in mind. So that's it. We're just factoring and crossing things out that match. If you have any questions, send me an email or ask a neighbor or whatever you need to do. Good luck.